In this video, I'll be discussing my project, Automating Geographic Inputs to Mini-Grid Distribution Maps in Papua New Guinea. For some background, Papua New Guinea has particular challenges with grid electrification. It's one of the least dense countries in the world, which is partially the result of terrain that's really challenging to navigate. It's a lot of jungles, mountain ranges, lots of small islands, and the fact that the population is so remote and widespread has meant that lots of people have problems getting access to the centralized electrical grid. And to meet the country's national goals of reaching 70% electrification in the next decade, investment is needed in mini grids. So, mini grids are power generating networks that are best suited for small communities with at least 100 or so households, and typically ones that are located further away from the grid, several kilometers away from existing power lines. Just a distance that makes it more efficient to build a separate power generating network than to connect and extend existing ones. They consist of an on-site source of power generation, like a solar panel, some inverters, chargers, other infrastructure and equipment, some energy storage usually, and then a distribution network that connects all the homes, businesses, and other community buildings to electricity. Now, the exact layouts and components of mini-grids can vary a lot depending on the specifics of each site, and in Papua New Guinea in particular, that makes it a real challenge to plan for mini-grids. The fact that the terrain is so remote and difficult to navigate means that it's very expensive to send engineers or surveyors or other people out to a specific site to take measurements. And that cost means that it's hard to know with any accuracy how expensive it will be to install somewhere. And that makes it really hard to get investment in these projects, which means it's hard to get them actually built. So my project is designed to take advantage of remote sensing imagery and help estimate mini-grid costs without actually having to travel to a site. So my work fits into other work on electrification in this particular setting. High-resolution population modeling has already identified viable and high-potential locations for mini-grids based on density and estimated electricity demand at those sites. Other work also estimates the most appropriate technology for a given site by comparing the levelized cost of energy across different generation technologies. So we know where mini-grids should be, and we know what generation method is probably most efficient there. The next step is planning the layout for a mini-grid project at a specific site. So my work builds on another ongoing project, which is creating a tool that takes an aerial image of a community, like this one, and then draws the most efficient distribution network, something like this, just a mock-up, on top of that, finding the shortest distance between all the buildings we want to connect. That means that we can estimate the number of power poles and the amount of power lines of each type needed, and that helps us get a cost estimate. And the biggest challenge with this work so far is that all of the buildings need to be hand labeled at the start, which is pretty labor intensive and limits how much we can share the tool with interested parties. So my goal for my project has been to automate the detection of those buildings so that the network mapper can function more efficiently. So I've experimented with a number of pre-trained models to do this with varying success, and this is one that I'm using right now, which is the segment anything model. This one I like. It comes with a dynamic text interface, so you can prompt it to identify buildings or trees or paths as a user, and it'll do that dynamically. It's not perfect at this point, but it's a good start. I'm still tweaking some of the parameters. And then once we have those buildings identified, then the network mapper can draw the distribution map, again, just a mock-up, and then we can go to estimating costs. So this tool, the left column, the quantities part, has the outputs of the network mapper, and then the unit prices on the right column are filled in with defaults that are just like from literature with benchmarking similar projects, but the user can edit those if they have better information, and they get a ballpark total costs. And then at the bottom, they can estimate the rest of capital expenditure costs if distribution materials are some given share of those costs. So again, just a rough ballpark, but hopefully this will help be a good start in encouraging investment and get more people access to electricity. Thank you for watching.